Hi all. Today we continue to study chapter 2 about motion. As we talked last time, L can exert a force on a moving object in the opposite direction of motion. This force is called L resistance. The magnitude of L resistance increases with the speed of the moving object. The speed of a falling object reaches the maximum when the L resistance is great enough to balance the gravity. This maximum speed is called the terminal speed. Terminal speed of an object depends on the object's size, shape, and mass. Terminal speed is 42 meters per second for baseball, 20 meters per second for a basketball, 9 meters per second for a ping pong ball, and 10 meters per second for a large raindrop. Newton developed 3 laws of motion. To describe the first law of motion, we first define what is force and what is net force. A force is any influence that changes motion or changes velocity of an object. For examples, gravity, air resistance, push, pull, and so on are all forces. Force is a vector. Gravity points to Earth's center. Air resistance directs in the opposite of the motion. Pushing force directs in the front, and the pulling force directs to the behind. Net force is a force not balanced out by one and more other forces. It is an unbalanced force, or the total force. For a body on a table, the gravity is balanced by the normal force. The net force on the body is 0, no net force. For a falling object, when it has not yet reached the maximum speed, the air resistance is not great enough to balance the gravity. Net force is not 0. Unbalanced. The first law of motion can be described as, if no net force on it, an object at rest remains at rest, and an object at motion remains the motion at a constant velocity. Constant velocity means constant speed and no direction change in a straight line. Before to learn about the second law of motion, we first give the fundamental quantity mass in more details. In physics, mass is usually defined based on its inertia. What is inertia? Inertia of an object is the reluctance of the object to the change of its motion or rest. It is caused by the interaction with the matter of the entire universe. Because of inertia, a passenger moves forward when the bus makes a sudden stop. In physics, we usually define mass as a measure of inertia. Usually we say that mass is the amount of matter that an object contains more matter an object contains, more mass it has. According to Einstein's mass-energy formula, mass is a form of energy. Atomic energy is converted from mass. We will learn this in more details in chapter 8. In chapters 8 and 9, the unit of mass is kilogram. Second law of motion. When net force on an object is not zero, the object accelerates. The acceleration of the object is proportional to the net force and inversely proportional to the mass of the object. The second law of motion states as net force on an object is equal to the product of mass and acceleration of the object. F equals ma, or A equals F divided by m. The unit of force is defined as Newton, shortened by N, with 1 Newton equal 1 kilogram meter per second square, which equals 0.225 pounds. Let's do an example. Find the force needed to push a 5 kilogram object at an acceleration of 2 meters per second. This is the question. According to the Newton's second law, F equals ma. Well, mass m equals 5 kilogram and acceleration a equals 2 meters per second square. Then we obtain the force equals 5 times 2 equals 10 Newton. The second example is to find the force needed when a tennis player serves a 60-gram tennis ball at 30 meters per second with a racket, which contacts with the ball typically in 0.005 seconds. Here the mass of the ball is 60 grams, which is equal to 0.06 kilograms. Considering the ball to be hit by the racket from rest to 30 meters per second in 0.005 seconds, we find the acceleration of the ball. A equals v2 minus v1 divided by t, that equals 30 minus 0 divided by 0.005 equals 6,000 meters per second square. So the acceleration is 6,000 meters per second square. Then using Newton's second law of motion, we have F equals ma equals 0.06, that's the mass, times 6,000, that's the acceleration. So the result for the force is 360 Newton. 360 Newton. Mass and weight are different quantities. Weight is the force with which an object is attracted by Earth's gravity. According to the second law of motion, the weight of an object with mass is given by W equals ma. The unit of weight is Newton, N. 1 pound equals 4.45 Newton. Weight can be varied, while mass cannot. At sea level, g, the constant g, acceleration, gravitational acceleration g, equals 9.8 meters per second square. On a top of mountain, this constant of g is slightly smaller than 9.8 meters per second square. So weight depends on the location, can be varied. Weight is a force, is a vector directing to the Earth's center. while mass is a scalar quantity. Weight unit is Newton, while mass unit is kilogram. So mass and weight are completely different. One is scalar, one is a vector. One is amount of matter, measure of inertia. Weight is a force, Earth's gravity. The third law of motion is described as when one object exerts a force on a second object, then the second object exerts an equal force in the opposite direction on the first object. So force on A by B, F1, equals negative force on B by A, F2. So F1 equals negative F2. That's the formula for the third law. If we call F1 as action, then F2 is reaction. Action and reaction are equal in magnitude, are opposite in direction, exert on different objects, and are the same type of the forces. For examples, frictions between walking foot and the ground, normal forces between box and the table, and gravity between Earth and Moon. They are all action-reaction, magnitude equal, direction opposite, on different object, same type of force. Section 12 is about a special two-dimensional motion, uniform circular motion, which is defined as a motion along a circle path. For an object to do a circular motion, an inward pull or force is needed. This inward force is called the centripetal force, which is proportional to the mass and the speed square, and inversely proportional to the radius. That is, Fc equal mv squared over r. Comparing with the second law of motion, we can see v squared over r is the acceleration, ac, called centripetal acceleration. For an example, find the centripetal force needed for a 1,000 kilogram car to move at speed of 5 meters per second along a circle with radius of 30 meters. From the centripetal force formula, Fc equals mv squared over r. Since m equals 1,000 kilogram, v equals 5 meters per second, and r equals 30 meters, we have Fc equal 1,000 times 5 squared divided by 30, which is equal to 833 Newton. This force is provided from the friction by the ground and the horizontal or the horizontal component of the normal force by the sloped ground. In addition to the three laws of motion, Newton's another significant work is the gravitational law. This law tells us every object in the universe attracts every other object with a force proportional to both of their masses and inversely proportional to the square of the distance between them. Expressing it as a formula, we have Fg equals big G m1 times m2 divided by r squared. Here, big G is called the gravitational constant, equal to 6.67 times 10 to the negative 11 Newton meter square per kilogram square. This is a universal